Good evening, class. Today we're going to look at 2.4, Evaluating Exponential Expressions. First, what we're going to do is do a bit of review, kind of recalling the exponent laws that we talked about before. So we're going to talk about the 5 different exponent laws, and hopefully you can remember what we do when we multiply powers, dividing powers, exponents, etc. Now, before I get there, I'm just going to do this bottom part here, definition, just to recall, review something that we talked about earlier to do with bases, powers, and we're going to introduce coefficient. So first thing I'm going to do is write down a power. So we'll start with 3. We go negative 4 squared. Or we might look at something like this. 3 x, go negative x to keep it the same, all squared. And what we're going to do is name these different components. And the first thing I want to name is this 3 that appears in front. Now this here is separate from this power here. We call this a coefficient. And that is the same for this one here. So, oops. Let's get the spelling right. Coefficient. So we have the 3 on both are called a coefficient. Now the only difference here is we have a 4 on one side, and the other side we have this negative x. So negative 4 and negative x. Now here is a number, and something we're kind of used to, but as we move forward, we're going to start using variables instead. And so a negative 4 and x, they're both just numbers, and we treat them the same. So let's bear that in mind as we progress through this. So here we have this entire thing that we've looked at before, and we call that entire thing here, we call that a base. And the same here, or sorry, we call that a power, power. And here, we call that also a power. And inside, we have this 4, this negative 4, we call that the base. Likewise, this negative x, we also call a base. Perhaps I was in a fortunate position for that power, but we'll just throw that in here. The 2, we call that the exponent. And here, we call that the exponent as well. So we have some terminology here, so when we continue talking about exponents and exponential expressions, we have, as a review, we have our base, which is the negative 4, which is raised to an exponent, which the entire thing, both the base and the exponent, are called a power. And the number that appears in front, we call that the coefficient, which I can see now I've spelled wrong. There we go. Coefficient. So now with that in mind, I'm going to use some of those words here. So the first law, or one of the first laws of exponents we can talk about, is what happens when we multiply powers. Multiplying powers. What do? Well, as an example, 3 raised to the 4th times 3 cubed. Well, what do? We take 3, we go 4 plus 3, which is 3 right to the 7th. So what we do is we add exponents. Now 2. What if we are dividing powers? Well, in that case, as an example, 4 raised to the 9th divided by 4 cubed, which can also be represented as 4 to the 9th and 4 cubed. Well, we get 4 raised to the 9th minus 3, which gives us 4 to the 6th. And that will, so then what do? We subtract exponents. Now, next. What about exponents separated by brackets? Well, exponents separated by brackets, let's give an example. Say 4 squared raised to the 3rd power, or 3rd exponent. Remember, we talked about how we use common language. We say to the power of, even though the entire thing is the power. So we've got to be careful about that. So we're going to write this as a single power, or single exponent. So we go 4, 2 times 3, which equals 4 to the 6th. And we will say, when we are separated by brackets, we multiply the powers. Any base raised to the 0 is, well, let's look at an example. Let's say 5 pi times 10 to the negative 23 divided by 4.2568 raised to the 0. Well, that is just equal to 1. Anything raised to the 0 is 1. Is 1. So if you see something complicated, good chance all you need to do is a good chance it's raised to the 0, and the answer is 1. And last thing we want to touch on is what do we do with negative exponents? Well, with negative exponents, as an example, 2 to the negative 2, well, first thing we can do is put it over 1, and we flip the fraction. So we turn it into a fraction, flip that fraction, and we end up getting 1 over 2 squared. And you can eventually evaluate that out to being 1 over 4 squared, but if I just ask you to make the exponents negative, then we flip. So at this point, let's look at some examples. Okay, so powers with coefficients. All right, let's do this. So say we have 3 times 2 raised to the 3rd power. Now in this case, since you don't have a negative, we could also write this as just 3 times 2 to the 3rd power, or we can, instead of the dot, we can just put brackets. We can do it that way as well. If there was a negative, we wouldn't be able to do that, but we don't always need to have those brackets, as you'll see later. So 2 cubed, well, 2, the 3, the 2 is just repeated multiplication. So 2 times 2 times 2. And then we get 3 times 8. So 2 times 2 is 4, times 2 is 8. And then we end up with 24. Next one, 2 to the x squared. So, 2 times x squared times 3 times x squared. You could also write this as just 2x squared times 3x squared. And what do we need to do? Well, we're going to take these coefficients, multiply them together, and then we will take these x's, and we will also multiply those together. So let's see what that looks like. So 2 times 3 and x squared times x squared. Remember what we do with bases with the same, if you have powers with the same base, we can, if we multiply, we add the exponents. So 2 times 3 is 6, and then times x squared plus 2. And we end up with 6x raised to the 4th. Now, another one. 4p squared times 1p raised to the 1. So here is an example where you might see it just like this. 4p squared times p. For our sake, let's add a 1 and a 1. So those, well, that's not a very good color. Let's put a 1 and a 1. So by default, we always assume there's a 1, a coefficient of 1 in front of the p, and we always assume there's a 1 in the exponent. So we can use that now. So we can take our coefficients and multiply them together. That's not very good. Let's just going to underline them. We'll take these coefficients, we'll multiply them together, and we'll take these powers and we'll also multiply them together. And so we'll get 4 times 1 and p squared times p to the 1. And that gives us 4, and then we have p, 2, and it's multiplied together, so 2p plus 1. And our answer ends up being 4p cubed. So again, the first one here, we had a numerical base, we can just evaluate it out, or frankly, well, that was the only option for that one. The next one here, we have variable bases, and they're the same, so we used our exponent law. Number 1 here, multiplying powers, then we add their exponents. And we did that for these two. In contrast, if we have 12w cubed divided by 4w, and we can assume there's a 1 on that w if there's nothing there. And so now we can multiply the bases, or sorry, multiply the coefficients, and then we can then multiply the two powers. And so divide the powers. We're dividing we're dividing here, not multiplying. So let me rewrite that. Divide the powers, and so divide the coefficients and divide the powers. So that looks like 12 divided by 4, and that's going to be w cubed divided by w to the 1. 12 divided by 4 is 3. And then we rewrite w cubed minus 1, which gives us our final answer of 3w squared. So notice we use the second exponent law here. When we divide powers, we subtract. And we've already used this first one here, or we haven't used that one yet, excuse me. We kind of actually did use it here, but that's it was kind of implied. So now let's do this one. 21k to the 7 divided by 7k to the 9. And so we're going to take the coefficients, we'll do the division, and we'll do the division with the powers as well. So let's write that out. 21 divided by 7 k to the 7 minus 9. And then we end up with 21 divided by 7 is 3, k to the minus 2. Now notice that's k to the minus 2 is there's a negative in the exponent, so we want that to be positive. So what we're going to do is we're going to rewrite that over 1, and we can take the k, we'll flip that to the bottom, so we'll end up with 3 over k squared. By moving the k squared and the negative 2 to the bottom, by moving this to the bottom, this becomes positive instead. So now we have a positive exponent, so 3 divided by k squared. And then lastly, 14t to the minus 2 divided by 8t to the minus 5. It looks intimidating because you've got some negatives. And you might be tempted to do the flip part right now, but I would hold off. You could absolutely do that and flip this first and make the exponents positive, in which maybe we'll show both ways here. So 14 divided by 8, and then we end up with t negative 2 minus negative 5. And that gives us 14 divided by 8. We can reduce the fraction to 7 over 8. And we end up with t cubed. So it became positive again. Now, we could also rewrite this as 14 over 8. And we can flip, we can send the t to the minus 5 up and the t to the negative 2 down. So we can flip the variable and the powers, flip the powers, so we can end up with t with the 5 on the top and t squared on the bottom. So notice that became positive, and that one became positive as well by flipping them. And now if this part doesn't make sense, don't worry about that and just do it the way we did on the left. But this way might be more comfortable for some, so 14 over 8. And then we have t, 5 minus 2. And we end up with 7 over 4. Oh, this is 7 over 4, my bad. 7 over 4, t cubed. And so that is all we're going to do for this lesson today. Another thing I want to share with some of you is how we will do some operations with a calculator. So that's one of the things we're going to do, that actual practice next day. So how can we use a calculator to do some of this, use some of these exponents? So what I'm going to do is I'm going to go to the practice work. And you can see right here, we have some of that practice work done. So what I'll do here is pull up the calculators. Just give me a moment.